Hi everyone, welcome to Irrational Maths Academy. In this video, we'll be discussing trigonometric chapter. So understand this chapter better, 4 or 5 things you need to remember. If you remember these 4 or 5 points which I say, then you can do any problem from the trigonometry chapter. First thing is you need to remember ratios. Next is ratio specific value of 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Then Pythagorean theorem, Pythagoras theorem you need to remember. Next, complementary angles of some specific ratios. Then identities. These are the fundamental things you need to understand to solve any problem from the trigonometry. If you are good at this 5, you can solve any problem from the trigonometry chapter. So let's start with the ratios. So in this trigonometry chapter, we'll deal with the right angle triangle. So here right angle triangle, right? So this is 90 degrees. This square symbol you can see, right? This represents 90 degrees. So either you can write it as 90 degrees, or if you just write down this, okay, if you draw this symbol, okay, it represents 90 degrees. Now let me take this as my angle. Either you can take this as also angle. So if this is my angle and if this is my right angle triangle, let me name these vertices. This is base. Let me represent it by B. And this is perpendicular length. Let me represent by P. This slant length is there, right? That is hypotenuse. Let me represent it by H. So if we had perpendicular length, by hypotenuse length, perpendicular length by hypotenuse length, we call this ratio as sine theta. Clear? We call this ratio as sine theta. Here I wrote theta, so I wrote sine theta. In some cases you might have seen A, B, C. So if the angle is here A, we'll write it as sine A. If the angle is B, we'll write it as sine B. Here I wrote a theta. That is the reason why I wrote a sine theta. Did you get it? So if I simplify here, P by H. Perpendicular length I represented by P and hypotenuse I represented by H. So perpendicular length by hypotenuse length ratio, we call it as what? Sine theta. This is the first ratio you need to remember. Is it clear? Similarly, base length by hypotenuse length. Base length by hypotenuse length. This ratio we call it as cos theta. Is it clear? Base by hypotenuse, we call that ratio as cos theta. We call this ratio as cos theta. Now, similarly, one more ratio. First is perpendicular length by hypotenuse length. Okay, this ratio we call it as sine theta. Second one is base length by hypotenuse length. We call it as cos theta. Total we have 6 ratios. The third ratio is perpendicular length by base. Perpendicular length by base length. This ratio we call it as tan theta. This ratio we call it as tan theta. Next, we got 3, right? These are first three important ratios. Now, if it is hypotenuse length by perpendicular length, that ratio we call it as cosecant theta. What we call hypotenuse length by perpendicular length, we call it as cosecant theta. Fifth ratio is hypotenuse length by base length, we call it as secant theta. Sixth ratio is base length by perpendicular length, we call it as cot theta. So these are the 6 important ratios you need to remember. Very, very important thing. Very, very important. If you can remember this, half of your work is done in trigonometry chapter. Next, we had some relationship between ratios. Sin theta, if you look at here, sin theta is what? P by H, and if you see cosecant theta is H by P. That means sin theta is equal to 1 by cosecant theta, or cosecant theta equal to 1 by sin theta. Similarly, if you see cos theta, cos theta is what? Base by hypotenuse. Secant theta is hypotenuse by base. So cos theta is 1 by secant theta, or secant theta is 1 by cos theta. Next, what is tan theta? Tan theta is what? Perpendicular by base. Is it? So, and cot theta is base by perpendicular. So, tan theta equal to 1 by cot theta, or cot theta equal to 1 by tan theta. This is a relationship you need to remember. Is it clear? Next, just now what we wrote? Sin theta equal to 1 by cosecant theta. Now, using this relationship, if I multiply both sides with cosecant theta, what happens? Sin theta into cosecant theta equal to cosecant theta by cosecant theta equal to 1. That is sin theta into cosecant theta equal to 1. So if you come across the situation where sin theta into cosecant theta, what you can substitute the value? 1. Similarly, cos theta equal to 1 by secant theta, or cos theta into secant theta equal to 1. Clear? And tan theta. Tan theta equal to 1 by cot theta, or tan theta into cot theta equal to 1. So wherever, okay, this relationship is required, we'll use this one. Clear? Next, we'll go for values. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So sin theta, these are theta values. If you remember these values, you can solve very quickly. Okay, sin 0 degree value is 0. Sin 30 degree value is 1 by 2. Sin 45 degree value is 1 by root 2. Sin 60 value is 1 by 2. And sin 90 degrees is 1. If you remember this 5 ratios values, that is more than enough. For cos, no need to remember anything. What you can do is reverse it. So cos 0 value is 1, Cos 30 value is 1 by 2. Cos 45 value is 1 by root 2. Cos 60 value is 1. See here, sorry, here it is root 3 by 2. So this is root 3 by 2. 1 by 2. And cos 90 degrees value is what? 0. Tan value if you want. Again, there is one relationship between tan theta and sin and cos. That is tan theta equal to sin theta by cos theta. Clear? And cot theta equal to cos theta by sin theta. Now, if I want a tan 0 value, tan 0 means what? Sin 0 degrees by cos 0 degrees. What is sin 0 degrees? 0. Cos 0 degrees is 1. 0 by 1 is 0. Next, tan 30. Tan 30 is nothing but what? Sin 30 degrees by cos 30 degrees. Sin 30 degrees is what? 1 by 2. Cos 30 degrees is what? Root 3 by 2. Root 3 by 2. If you know a by b fraction by c by d fraction, what we can write? A into d, b into c. Remember here, first numerator into second denominator by first denominator into second numerator. Similarly here, 1 into, that here 1 into 2 by 2 into root 3. 2 gets cancelled. 1 by root 3. Is it clear? So tan 30 value is what? 1 by root 3. Tan 45, look at here. Tan 45, what you'll get? Sin 45 by cos 45. Sin 45 is 1 by root 2. Cos 45 is 1 by root 2. So what you'll get here? Answer 1. And tan 60 degrees. Tan 60 means what? Again, sin 60 by cos 60. So sin 60 is what? Root 3 by 2. By cos 60 is what? 1 by 2. Again, a into d by b into c. So what I'll get? A root 3 by 1, that is nothing but root 3. Root 3 I'll get. And tan 90 degrees. Tan 90 degrees is what? Sin 90 degrees by cos 90 degrees. So sin 90 degrees is what? 1. Cos 90 degrees is what? 0. So 1 by 0 is what? Undefined. So here cos 90 degrees is what? Undefined. Clear? You can find out the values of cot. As I said, cot value is what? Cos theta by sin theta. Similarly, cosecant also you can find it out. Cosecant is what? 1 by sin theta. Similarly, secant theta also. Secant theta is what? 1 by cos theta. So first only if you remember this sin theta, okay, you can write all the other ratio values. Is it clear? Still, if you have doubt, you can ask. This is the second important thing. Next, complementary angles we will discuss. Okay. See, complementary. What is complementary angle? If two angles is 90 degrees, we call it as, if sum of the two angles is 90, we call it as complementary angles. And if sum of the two angles is 180 degrees, we call it as supplementary. Is it clear? Now, remember this thing, sin 90 minus theta. Sin 90 minus theta, we get cos theta. If it is cos 90 minus theta, cos 90 minus theta will get a sin theta. Is it clear? Remember this pair. Similarly, tan 90 minus theta. Tan 90 minus theta is cot theta. Cot 90 minus theta is tan theta. See, you cannot remember everything in one day. So every day, first what you can do is, first you try to remember ratios. Next day, try to remember identities. Next day, try to remember this ratio values. So it will take like 3-4 days. And if you every day if you spend like half an hour, that is more than sufficient to solve this trigonometric chapter. Next, cosecant 90 minus theta is secant theta. Secant 90 minus theta is cosecant theta. Is it clear? See, you will understand this one very well when you solve problems. As of now, try to remember all those things. Is it clear? Next, we'll go for identities. Very, very important for solving, okay, trigonometric problems and proving. Identities. We have 3 identities. We have 3 trigonometric identities. First is sin squared theta plus cos squared theta equal to 1. Sin squared theta plus cos squared theta equal to 1. Let us change in different forms. Cos squared theta equal to what happens? 1. If I take to that side, what happens? Minus sin squared theta. Or if you look at here, in any case, if they ask us to write down cos theta in terms of sin theta, you can write down this way. And see, cos squared theta equal to 1 minus sin squared theta, or cos theta equal to under root of 1 minus sin squared theta. Is it clear? From this identity only we wrote this one. Similarly, if I want a sin theta in terms of cos theta, what I can do is leave a sin squared theta here only, equal to 1 plus cos squared theta, right? If I take to that side, what happens? 1 minus cos squared theta, or sin theta. If I want sin theta, 1 minus cos squared theta. Okay, these are the different forms you can write from this single identity. If it is sin squared theta plus cos squared theta, we can use the value 1. Or if we come across the value 1 minus sin squared theta, in that case we can write it as cos squared theta. Or under root of 1 minus sin squared theta, we can write it as cos theta. Similarly, 1 minus cos squared theta, we can write it as sin squared theta. Or under root of 1 minus cos squared theta, we can write it as sin theta. This is first identity. Next, 1 plus tan squared theta. 1 plus tan squared theta equal to secant squared theta. Very, very important identity. Second identity. Okay. Now, I'll leave 1 here. And if I take this tan squared theta to that side, what happens? Secant squared theta minus tan squared theta, value is what? 1. Or if you look at here, a square minus b square equal to what? If you remember this formula, so it is in the form of a square minus b square, right? So if it is in the form of a square minus b square, can I write it as secant theta plus tan theta into secant theta minus tan theta. A square minus b square equal to 1. I can write it as a plus b, a minus b. So this is what I wrote. Is it clear? Next, if I want secant theta plus tan theta, secant theta plus tan theta, so secant theta plus tan theta equal to 1 by, if you look at here, this is in product. If it is in product, if I take this to this side, what happens? It becomes in the denominator. Okay, we get this in the denominator. 1 by secant theta minus tan theta. Similarly, if I want secant theta minus tan theta, I can write it as 1 by secant theta plus tan theta. One more form, we can write it as tan squared theta equal to secant squared theta minus 1, or if I need just a tan theta in terms of secant theta, secant squared theta minus 1. From this identity, we can write in different forms. Okay, wherever it is required, we use that form. But you need to remember, okay, the box one. When you practice, you will get a how to change, okay, as per our requirement. Last identity, basic, that is 1 plus cot squared theta equal to 1 plus cot squared theta equal to cosecant squared theta. Clear? So this I can write it as, let me draw the box for this. So cosecant squared theta minus cot squared theta equal to 1. Similarly, again here a square minus b square I can see here. So here I can write it as cosecant theta minus cot theta into cosecant theta plus cot theta equal to 1. And if I need cosecant theta minus cot theta, I can write it as 1 by cosecant theta plus cot theta, or cosecant theta plus cot theta, I can write it as 1 by cosecant theta minus cot theta. And one more thing, you can write it as cot squared theta equal to cosecant squared theta minus 1, or if I need just cot theta in terms of cosecant theta, we can write it as what? Under root of cosecant squared theta minus 1. Is it clear? So for example, let us see here, if cosecant theta minus cot theta, okay, cosecant theta minus cot theta values given, and if they ask us to find out cosecant theta plus cot theta, if they ask us, if we from this identity we can write it as cosecant theta plus cot theta, what we know, 1 by cosecant theta minus cot theta. Clear? So we already know 1 by cosecant theta minus cot theta means what? K. Is it clear? This is example problem. So you can solve any problems. Okay, if you understood all this identities, ratios, values. Okay, we'll solve problems in the next video. Thank you.